So let us start chemistry part 2. In a first order decomposition reaction, the time taken for the decomposition of reactant to 1/4 and 1/8 respectively T1, T2. 1/4 to 1/8. So continuation only. 1, 1/2, 1/4. That means 2 half-lives. Continuation 1/8. 3 half-lives. So T1 is equal to 2 half-lives. T2 is equal to 3 half-lives. So T1 by T2 is equal to 2/3. Okay, option 4. Next, 52. Match the following. Carbocation species that can supply pair of electron. No, deficiency. Species receive a pair of electrons. sp2 hybridized carbon atom with empty p orbital. So actually carbocation accept electron pair also, but it is a single matching. sp2 hybridization is another matching for the carbocation because 6 electrons present only and deficiency of electron. So it is receive pair of electron correct, sp2 hybrid correct. So first we will take single matching only. Single matching, this is sp2 hybridization. You can take 3 suppose. Free radical. Free radical is sp2 or sp3 hybridized with one unpaired electron. That is correct one because CH3 one electron is free. sp2 hybridized. But sp3 means exceptional example CF3 or more electronegative element will attract this electron also to take part in the hybridization. Therefore, the structure change like this. Number same only, one only, but this is now sp3 hybrid orbital. This is pure p orbital because it is sp2 hybridization, one p left. This is completely sp3. So, one of the electron in the sp3, remaining 3 bond pairs with fluorine. That is CF3. So, 4. Nucleophile, electrophile, just opposite to nucleophile supply, electrophile acceptor. So, supply means 1, electrophile acceptor receive 2. So, 3, 4, 1, 2. Option 4. Next, question 53. A gives rise to B, NaOH and hydrolysis. B gives C, ETOH, ethanol and sulfuric acid followed by heating. A shows positive Lessine test. Positive Lessine test for nitrogen and molar mass is 121. That means it is a nitrogen containing compound. Okay. Molar mass 121. Next, B gives effervescence with aqueous NaHCO3. That means A to B hydrolysis in basic medium followed by acidification. So, as for the given compounds, it must be amide or amine, nitrogen compound. But amide react with NaOH. to form COO-Na followed by hydrolysis COOH. So COOH is possible by the starting compound amide. COOH gives effervescence. Acid plus alcohol gives esterification. Okay, so A must be amide and 121 molar mass. So you can check now amide with 121. This is 78, one loss, 77, 79, 79 plus 12, 89, 91, 91 plus 14 or 7 carbons. So 7 carbons, so 7, 84, nitro, 1 oxygen 16, 1 nitrogen 14 and 2 plus 5, 7 hydrogens, 10, 21, 121. So correct. C is equal to esterification, that is benzoic acid plus alcohol. pH COOH plus HOET. pH COOET is called compound C. Because amine plus NaOH no reaction. Amine is a base only. NaOH also base only. Just mixable but not reaction. That's why A must be amide only. Benzamide. C6H5 CONH2. So no other option possible because in this one there is no possibility of amide. This amine, this amine, this amine only. That's the only option A correct. Next 54, which is the following set of reagents for conversion of ethyl benzene to this compound. So starting compound ethyl benzene. So we want bromine and double bond. Alcoholic OH requirement because dehydrohalogenation. So halogen requirement, but two types halogens. One on the cycle, that is called electrophilic substitution. One on the side chain, radical, free radical mechanism. Suppose you take first bromination, then bromine in catalyst gives ARSC, aromatic electrophilic substitution, OP director. So para better, take para bromo as major product. Next chlorination, sunlight, free radical substitution. At benzyl position, this carbon is called benzyl carbon. Next alcoholic KOH, dehydrohalogenation. CH double bond CH2 Br. So correct set. First free radical, first electrophilic substitution, next free radical substitution and alcoholic KOH. Any other possibility? Suppose this is bromine is possible. Third option also contains, sorry, last one not correct. Third option low, if first two correct, that is bromine anhydrous AlCl3 substitution electrophilic, chlorine radical substitution correct, but the last aqueous KOH given not correct. And check the last option, chlorine anhydrous AlCl3 is correct na, chlorination, but correct for the mechanism wise but not element. We want element bromine, this gives element chlorine, that's why last one is not correct na? Only First one correct. Option 1. Next 55. 1,2-dibromocyclooctane. 1,2-dibromocyclooctane. Alcoholic KOH. Okay. Conjugated double bonds. Next NaNH2. Oh, it is nothing but both of them same only, like this. CCl. First alcoholic KOH dehydrohalogenation to form vinyl halide. Vinyl halide. So CH double bond CClH. Vinyl halide is resonance stabilized. Therefore, next halogen dehydrohalogenation not possible with alcoholic KOH because of resonance stability. Very strong base requirement than alcoholic KOH. That's why if first two steps are nothing but same function, dehydrohalogenation only. First one is a direct one with bromine and H. Second one, vinyl halide undergoes dehydrogenation with only strong base NaNH2 to form alkyne series, because again forms double bond here, alkyne series. That's why it must be alkyne series. Next step, NaNH2 gives C triple bond C. Okay. Next, mercuration. Symmetry compound can add any one side. H plus OH minus, or break double bond, add O and H2, or tautomerize to form ketone. Next, zinc amalgam and H plus. Zinc amalgam H plus, again reduction. Ketone reduction back to form cyclooctane. Clemensen reduction. That is zinc amalgam and H plus. So answer 2. So first one, small confusion, that is about double bond conjugation or alkyne, because it is 2 KOH, 2 moles of KOH or 1 mole of KOH. That's important. 1 mole of KOH using only, but not second molecule, because second molecule of KOH unable to eliminate this halogen atom. That's why it undergoes alkyne series formation. But first one, lows, we can take first step lo, we can take bromine, here H present, here also H present. Alcoholic KOH, here one H present. It is Sedgwick rule, not Hoffman rule. Less number of H, this is less number only. So this H and this B are elimination, but not this H. It's CH2 formula. That is why it is taken as first vinyl halide. Next step, NaNH2. That is vinyl halide and NaNH2, one more dehydrohalogenation into alkyne series. Okay, so don't take this side because it's CH2 present. That is Hoffman rule elimination. We want only Sedgwick rule elimination because this is a alcoholic AOH, not bulky base. Okay. Next, 56, statement 1, homoleptic octahedral complex formed using monodentate ligands will not show stereoisomerism. Not possible because all of them are same, so plane of symmetry present. Homoleptic same ligands, that is called MA6. MA6. No geometrical, no optical because all atoms are same. Plane of symmetry present. So correct one. Cis trans platin are heteroleptic no, they are homoleptic complex. So no, hetero complex, hetero only but not palladium, it is a platinum. PT NaH3 twice to different ligands is called heteroleptic complex. But platinum, not palladium. So second false. First one only correct one. Because second one lo cis trans both of same structures, but metal atom is different. Same structures means same formula, but cis and trans, one on adjacent, one on opposite. This called cis transplatin, and second one is called cisplatin. Same site. Okay. So option 1 correct, second false. Option 4. Next, 57. Atomic number of the element from the following with the lowest ionization enthalpy. First you take elements only, 32. 30, 31, 32. Follow trend wise. 34, 35. These are the fourth period elements. Suppose like zinc reference, 4s2. Fourth period elements. Next, 19. Also same before that one. Potassium. 19, 32, 35. Along the period, ionization energy increases. Next to 87. 87 means alkali metal because 86 radon, 87 alkali metal. So here only last, that is cesium. 19 potassium plus 18, 37 plus potassium, rubidium plus 18, 55 cesium plus 32, sorry, cesium francium, radioactive element francium. So top to bottom ionization energy decreases. So francium is the lowest value of ionization energy. 87 atomic number 3. Okay. Next, 58. Which of the following binary mixture does not show behavior of minimum boiling azeotrope? Means positive deviation. Does not show minimum. E minimum boiling azeotropes property of positive deviation. So check now. First one is positive deviation because iodine bonds decreases. Second one is negative deviation due to hydrogen bond formation. hydrogen bond formation. Third one, positive deviation, because polar and non-polar net force of attraction decreases. This is all same, positive. So negative deviation gives maximum boiling azeotropes. If first one low number of bonds decrease, meaning is called water molecule contains 4 bonds. But the acetone is reduce the number of bonds. That means bond dissociation. That's why hydrogen bonds decreases. Third one low net force of attraction decreases because polar non-polar. Polar strong dipole-dipole attraction, but non-polar will reduce the dipole-dipole attraction. Reduce dipole-dipole attraction. This is same hydrogen bond breaking by the chloroform. That's why bond dissociation. So bond dissociation or force of attraction dissociation is called positive deviation, and the formation of hydrogen bonding is negative deviation. That is phenol and aniline forms of hydrogen bonds. That's why 2. Next, HA gives rise to H plus A minus. Freezing point depression of 0.1 molality aqueous solution of monobasic weak acid is 0.2. Dissociation constant of the acid is Ka, find out. So first Ka is equal to, for weak acids, C alpha square by 1 minus alpha. So depending on data value, you can neglect 1 minus alpha. Otherwise take full formula. If alpha is 0.1 or 0.2, you can consider them. If 0.01, you can neglect. So check first the alpha value. Then from the Van 't Hoff factor, what is value? Your freezing point depression. Delta TF is equal to Kf into molality into I factor. 0.2, 1.8, 0.1 I. So I is equal to 0.2 by 0.18 is equal to 2 by 1.8 or 20 by 18. 10 by 9. Okay. I factor. Next, dissociation I factor. I factor 1 minus alpha plus n alpha, dissociation. 10 by 9 is equal to 1 minus alpha plus 2 alpha, because 2 particles. 1 plus alpha. Alpha is equal to 10 by 9 minus 1. 1 by 9. 1 by 9 is not negligible value compared to 1, because closer to 1. That's why take full formula. Ka is equal to C 0.1. Alpha 1 by 9. 1 minus 1 by 9. 9 minus 8 by 9. So Ka is equal to 0.1 into 1 by 9, 1 by 9 by 8 by 9. So 1 9 cancel. Next 0.1 by 72. 0.00138. So 1.38 to 10 raised minus 3. If the alpha value 0.01 or below 0.01, you can neglect it. But to 0.1 closer, not neglected. That's why take full formula 1 minus alpha only. Next, IUPAC name for this compound. Functional group is alcohol. Next priority double bond. Four ethyl cyclopent 2 in 1 ol. Option 4. Correct order of spin only moment. Cu plus 1, Cu plus 1, D10, D9, D4, D3, 0, 1, 4, 3 number of unpaired electrons. So highest value 4, 4, 3, 1, 0. Option 3. Next, 62. Which of the following reactions will not lead to desired ether formation in the major product? Isobutyl, secondary butyl code given, N-propyl, butyl, T-butyl, tertiary ethyl. Okay. So ether not formation. So Williamson synthesis condition only apply. Williamson synthesis condition. Rx plus NaOR dash SN2 reaction to form ROR dash. But the condition is Rx lo R value methyl or unbranched primary not equal to secondary, not equal to tertiary and equal to allyl and benzyl. But to R dash no condition. R dash no condition means can use any compound. R dash nucleophile. Okay. So sodium butoxide, that is a nucleophile, ethyl bromide primary, correct one, unbranched primary. Next, cyclohexoxide methyl bromide, correct one. Next, sodium butoxide, yes, sodium benzoxide, sodium benzoate, sodium phenoxide, phenoxide plus N-propyl bromide. So phenoxide nucleophile, and N-propyl one Rx, correct one. Isobutoxide, no problem. Nucleophile can use no condition, but this is not possible. Rx cannot be equal to secondary or tertiary. So this is secondary. Rx cannot be equal to secondary. That's why not possible. Option 4 not possible. Remaining 3 possible. So only one condition once again. Rx equal to methyl unbranched primary and secondary, not equal tertiary, not secondary. Allyl benzyl okay. That means what 4 groups okay. Methyl group, unbranched primary group and allyl group, benzyl groups. But NaOR no condition, can use any type of nucleophiles. Next, compound mass 0.21, CHO containing mass of water, compound carbon dioxide given. Find out percentage of hydrogen oxygen in the compound is. That means oxygen is 100 minus. Percentage of C is equal to 12 by 44. Mass of carbon dioxide by mass of compound into 100. 12 by 44 into carbon dioxide 0.307. Compound 0.21 into 100. Same percentage of H equal to 2 by 18 into mass of water by mass of compound into 100. 2 by 18 into mass of water 0.127. Compound 0.210 into 100. Percentage of oxygen equal to 100 minus of percent of C plus percentage of H. Okay, that gives on solving option 2. Next, 54. Compound given is alpha amino acid, alpha carbon, alpha amino acid, alpha amino acid. Alpha amino acids have tendency to exist as zwitter ions, but depending upon the isoelectric point, this is one amine, one acid. Generally, one amine, one acid means isoelectric point, around 6.3, at which exists zwitter ions, exist as or formation of zwitter ions. But question given is pH 2. 2 is below isoelectric point. That means nothing but addition of acid. So addition of acid, I take first zwitter ions. CH3 twice COOH NH2 at pH 6.3 CH3 twice COO minus and NH3 plus. This is the structure of the compound at pH 6.3 isoelectric point. Now addition of pH 2, that means addition of acid at concentrated H plus ions means high value of H plus ions. H plus ions undergoes protonation on the COO minus neutralization. NH3 plus CH3 twice COOH, that is called cation. And now it shows cataphoresis, means cation moved towards cathode on electrolysis. That phenomena electrophoresis. Electrophoresis means migration of zwitter ions in the corresponding pH medium towards anode cathode. But corrected to isoelectric point, no moment, because that is double salt or double charges, plus and minus, dipolar charges, plus and minus. Okay, that's for inner salt also. This is for pH 2. Next to pH 10 means addition of strong base. Add OH minus ions. OH minus ions. Then OH minus will absorb H plus ion from the NH3. Loss of water take place from the NH3 NH2 formation. That is called basic medium base formation. This is conjugate base remains same only. COO minus is called anion, called anaphoresis. Okay, that's why respectively A acidic medium converting to cation, ammonium ion, B anion, that is COO minus, option 1. And this amino acid is called neutral amino acid, meaning is called one amine group and one acid group. Generally around 6 to 6.3 is called isoelectric point, at which it exists as zwitter ions. Zwitter ions converting it to cation or anion depending upon the corresponding medium addition. Okay, correct statements for the element atomic number 9. Atomic number 9, fluorine. One S2, 2S2, 2P5. Take orbital diagram, 1S2, 2S2 and 2P5. First one, there can be 5 electrons with ms value plus 1 by 2 and 4 electrons with minus 1 by 2. Check. 1, 2, 3, 4, 5. because in the case of this p orbitals, first clockwise fill up, next pairing it anti-clockwise. Correct one. Then anti-clockwise 1, 2, 3, 4. There is only one pz orbital. Correct one. One electron. But we cannot confirm that one electron pz. So which is pz here? Don't take px, py, pz because they are having degeneracy. Same energy, direction different one. So we cannot predict that which is z. Anyone is z. That's why it is not to decide it. Last electron goes to orbital with n is equal to 2, l is equal to 1. Correct na? Principal number 2. Azimuthal number 1, p orbital. Correct one. Sum of angular nodes all atomic orbitals is 1. Angular nodes also called nodal plates equal to L value 0, 1, 2, 3. S, P, D, F. So 0, 0, 1, 1, 1 because Px, Py, Pz 3 orbitals. So sum is equal to 3 but not 1. So this is not correct. Other side, D statement. So AC only correct. Option 2. Next, 66. Number of species from the following that are involved with sp3d2 hybridation. sp3d2 hybridation means D last one, outer orbital complex. Outer orbital complex means weak field ligand. Ammonia strong ligand for cobalt plus 3. SF6 normal sp3d2, correct one. Fluorine weak field ligand, but atomic number 20 plus 3 state. Plus 3 state of chromium is Cr3 plus 3d3 because removal of 3 electrons. 4s1 no 3d5 2 loss 3d3, but up to d3 no effect of ligands. This is called 1, 2, 3, 4, 5. Next 4s and 4p. Vacant 3d3. So maybe strong or weak, same configuration. This part will undergo now hybridation. D2sp3. So not correct. COF is correct one because weak ligand plus 3 state sp3d2. MnCN 6 times. Mn plus 3 state 3d4. Cyanide strong ligand. Therefore, this also D2sp3 hybridation. Inner complex. MnCl6 weak ligand. Same compound, weak ligand. sp3d2. So, how many compounds? SF6 correct. COF6 correct. MnCl6 correct. Option 4. 3 compounds. SF6, COF6, MnCl6. But the question ambiguity because NTA key given answer 3. Third option. So like maybe mistake or number mistake or answer mistake because compounds 3. Option 4. Compounds 3 option 4. But here taken as option 3 compound 4 taken. That's why maybe mistake in that one. But they given NTA 3 is an option. I think correction will be given or not given. Because check once again. This is a strong ligand, 3D6 pairing takes place, therefore due to sp3. This is normal only. CRF6 D3, so that's why normal D2 sp3. Because up to D3 no effect of ligands. COF6 okay, weak ligand. MnCN6 D2 sp3 because D4 means it undergoes one electron pairing. One electron pairing. 1, 2, 3, 4. So this part undergoes D2 sp3 hybridization. MnCl6 sp3 hybridization. So that's why option 4 compounds 3. Okay. Next 67 reagent and functional groups given. Sodium bicarbonate, carboxylic acids. Property of only acids. Acids sulfonic acid also. Acid, sulfonic acid and also picric acid. And also 2,4-dinitrophenol also. Sulfonic acid, carboxylic acid, picric acid and 2,4-dinitrosulfonic acids. Neutral ferric chloride, phenolic group, that is 3. Violet complex. Ceric ammonium nitrate can test alcoholic group, red coloration of complex. Alkaline cheminophore base reagent test for unsaturation 1. So 2, 3, 4, 1. Option 1. Next, this is their intra-condensation only. So aldehyde ketone, very simple one. Aldehyde compulsory electrophile. It must be nucleophile ketone because ketone less reactive. It will supply only alpha H. Function group alpha carbon, alpha carbon. Take numbering, it must be 5-member or 6-member cycle. 1, 2, 3, 4, 5, 6, 7. So here 7, here 5. Suppose first take 5. Here 2H from alpha center and this O elimination as water molecule. That is aldol condensation. So 5-member cycle. 1, 2, 3, 4, 5. 1, 5 connection. 2 same, 3 same, 4 same. 5th 1, 5 joined double bond. 1, 5 connected by double bond. Okay. 1, 5 by double bond. Next to fill up the branches. Branch for 5th one. Correct na? Because 1, 2, 3, 4, 5, 6, 7. Next to check 4th option because if you take 7-member cycle, here 2 alpha H loss. So in this case 2 alpha H elimination with the same O2. Then 1,7 cycle. 1, 2, 3, 4, 5, 6, 7. 1,7 connect by double bond. Next fill up the branches. 1 no branch, 2 no branch, 3 no branch, 4 no branch, 5, 6th has a branch. So there are 2 possibilities given here. Aldol condensed for major product given. Among 5-member and 7-member cycle, stable is called 5-member cycle. Stable is called 5-member cycle. Okay, option 1 correct from the 1, 5. So 1, 5, 1, 7 lo always priority given to 1, 5 cycle, that is 5-member cycles. Okay, suppose if 5-member not possible, then go to 7-member only. But there are 2 possibilities present, 5, 7, 5 priority. Next 69, NiCO4 times pairing takes place 4s0 3d10. Nickel cyanide, nickel plus 2 state, the nickel 0. 3d8, this also pairing take place. Pairing in the easy level, that's called Joule-Thomson effect. DsP2 hybridization. Nickel chloride weak ligand, normal only, no pairing. Same 3d8, no pairing for the nickel chloride. 1, 2, 3, 4, 5, 6, 7, 8. Manganese bromide, Mn plus 2 state, plus 2 state, 3d5, weak ligand, same 5 electrons, no pairing. This is sp3 hybridization because 4s0, 4p0 undergoes hybridization. 4s0 and 4p0 undergoes hybridization, called sp3 hybrid. Tetrahedral, 0 moment, A3. Nickel cyanide, DsP2, square planar, 0 moment, B2. Nickel chloride tetrahedral, but two unpaired electrons because this is 3d8, sp3 hybridization, 4s0, 4p0 under hybridization. So that's why tetrahedral with 2 1 means root of 2 into 2 plus 2, nearly 2.8. This was tetrahedral only, but 5.9 because 5 electrons. So 3, 2, 1, 4. 3, 2, 1, 4 option 3. Next 70. Statement 1. H2SE more acidic than H2TE. OH, SH, SEH, TH. Down the group, atomic size increasing, bond length increase, bond energy decrease. That's why easy to loss of H plus and removal of H plus from the tellurium. It is more acidic. So 1 false. H2SE has higher bond enthalpy, means bond energy, than for the dissociation of H2TE. Correct one, because bond energy top to atom decreases. So 1 correct, 1 false, 2 correct, 1 false, 2 correct. Option 4. Okay. 71. Resonance energy of X2Y can be represented as. So there is a structure of compound X2Y given. Enthalpy formation of X2Y. One molecule X2 plus of Y is equal to Y gas. That means of Y2 molecule, gaseous state. X2Y, 80 kilojoules. Magnitude of resonance energy is dash kilojoule per mole. So that means enthalpy formation given already, 80 kilojoules. But again bond enthalpy given, means this experimental value. Now check the theoretical value. From the bond enthalpies, from bond enthalpy, delta H naught F, bond enthalpy reactant minus bond enthalpy products. Reactants are one triple bond X plus half molecule of Y double bond Y minus products X2Y, double bond X and double bond XY in this one, because any one structure can be taken. So product equal to double bond X, double bond Y. triple bond X value 940 half into double bond Y2 value, third value 500 minus double bond X means second value 410, double bond Y XY 602. Okay, that means we have taken this structure because they are resonance compounds. From data value, this not given, XY not given. That's why I take this molecule. So 250 plus 940, 1190 plus 400, 1000, 1000, 602, 410, 12, 1012. So 1190 minus 1012, 178. Now resonance energy equal to, it must negative value only, a very important one. So this is 80, this is 178. Therefore 80 minus 178, it should be negative value. So 80 subtract minus 98, but magnitude only. Actually resonance negative value always, but we want only value 98. Okay, that means we can take this formula as a experimental minus theoretical. Delta H naught F experimental minus delta H naught F theoretical. But if we don't know this formula, compulsory value must be negative only. That is important. Because negative means energy liberation, stability increases because of resonance effect. Okay. Next, electron energy in the first Bohr orbit is minus 13.6. Energy of electron in the first excitation state of beryllium is direct formula only. Energy of hydrogen by energy of beryllium minus 13.6 into Z square by N square minus 13.6 into Z square by N square. This value given minus 13.6. Take this X value is equal to Z square 1 square by 1 square because ground level. This is Z beryllium 4 square by which orbit? First excited means N value 2, 2 square. Okay, 4 by 16. X equal to 13.6 into 16 by 4. 13.6 into 4. 54.4. Take 54. Okay. Next 73. 20 ml sodium iodide gave 4.74 grams of silver iodide when treated with silver nitrate. So first equation is sodium iodide NaI plus silver nitrate AgNO3 is equal to AgI plus NaNO3. This equation. Question given is this is 20 ml sodium iodide. This is PPT given, silver iodide PPT 4.74 grams. molarity of sodium iodide is. Apply the formula of equivalence. N1 V1 equal to N2 V2. Okay. Normality into 20. This current to mass form. Mass by equivalent mass into 1000. So N into 20 is equal to mass 4.74. Equivalent mass of Ag 108, iodine 127, 235. Because n factor value 1 only, so 235 into 1000. Therefore, normality equal to 4.74 into 1000 by 235 into 20. 1.0082, take 1 only. Normality, molarity both are same, no? Because n factor 1 for NEI. So, molarity also equal to same, 1. Okay, next 74. Equilibrium constant for decomposition of H2O given. H2 plus R4 delta Z naught delta Z naught plus or minus plus given delta Z naught. Okay. K also given 2300. K total pressure at equilibrium 1 bar. Under this condition, degree of dissociation of alpha find out. So H2O gives rise to H2 plus R42 100 1 minus alpha by 2. Okay. Total moles equal to 1 plus 0.5 alpha. Now Kp equal to 8 into 10 raised to minus 3 is equal to pressure of hydrogen. Total pressure is 1 bar. 1 into alpha by 1 plus 0.5 alpha. 1 into 0.5 alpha by 1 plus 0.5 alpha. Power of 1 by 2 by H2O gas 1 into 1 minus alpha by 1 plus alpha. Assume alpha is neglected with respect to 1. That means 8 into 10 raised to minus 3 is equal to alpha by 1 plus 0.5 alpha zero point 0.5 alpha by 1 plus 0.5 alpha root of by 1 only, because 1 alpha negligible compared to 1, therefore 1. Can take one more, this also can take 1 plus na, so that's why alpha into 0.5 by 1 by 1 root of alpha by 2. So this gives alpha 1 plus 1 by 2 3 by 2 by root 2. So on solving, alpha becomes 5 5.03 10 raised to minus 2. Okay. So here itself 1 plus alpha 0.5 taken as 1 only. That's why these are neglected. So only here only 1, no, here just only 0.5 alpha root of. That is this step, alpha 0.5 alpha root of. Okay. So nearly 5. Next 75. Following reaction given, reaction is conducting with ratio of 10 raised minus 6 chromium by dichromates. pH of the solution at which EMF of the cell is becomes 0. First, the next equation, E is equal to E naught minus 0.059 by N log products by reactants. Products are Cr plus 3 whole square, water no need, liquid by H plus raised to 14 Cr2O7 2 minus E0 E naught equal to 1.33 minus 0.059 by N factor 6 because 6 electrons give directly. Take 0.06 nearly. This ratio value given 10 dash minus 6 by H plus raised to 14. So 1.33 is equal to 0.06 by 6 log, we take same like 10 raised minus 6 by H plus and raised to 14. 0.01. So come to here 1.33 by 0.01 is equal to log 10 raised to minus 6 minus of log H plus raised to 14. 1.33 10 raised to minus 2 minus 6 minus log of H plus and raised to 14. 14 log H plus. So 6 taken this side, 133, 142. 133 plus 142. 142 is equal to minus log, it means 14 log H plus ions. Minus log H plus is called pH. So 142 is equal to 14 into pH. So 142 by 14 nearly 10 only. 10.1 taken as 10. So pH nearly equal to 10. If we take 0.059 gives 10.09. So question in nearest value 10 taken. Okay, na? Because H2O pure liquid 1, therefore taken as only dichromate to chromium ion E naught value, E cell value 0, E naught value 1.33 minus 0.05 products by reactants. So pH equal to 10. Okay, thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.